Alrighty, ninth grade. Let's get started with this exam review for Unit 3. In terms of Unit 3 is about triangles, right? All about triangles. So let's go ahead and get right into it. The first couple slides here, rules for triangle congruency. I've given this to you today in class, but I want to make sure that you all have it somewhere as well in this video. The triangle congruency rules are as follows: SSS, right? SAS, ASA, AAS. This RHS is what we called it LH, right? That's leg hypotenuse theorem. It's also known as RHS, but don't worry about that. The name doesn't matter. Also remember that these only work with right triangles, right? These only work with right triangles. So don't forget that as well. And I'm just talking about this particular one here. Okay? All of the other ones work with all the other triangles. And of course, SSA is not sufficient for congruency. Okay? It makes two different triangles. And then there's another one that it's not mentioned here because it's not a real theorem. We call it AAA. Do not make the mistake of using this. This is what we call donkey theorem. Remember? It doesn't make sense. It doesn't work. We cannot prove triangles congruent by just the angles alone. All right, let's go ahead. Here's another one. Another little chart here for you. Make that a little bit bigger there. Okay, so here's this as well. You want to review this. I'm going to push pause and kind of see what the different special segments and points in triangles are. Remember, the points of concurrency here is where the segments meet, right? Where the line segments meet. And this is pretty self-explanatory because it gives you a little example in each of these as well. Alrighty, let's go on. Let's go ahead and take this first example here. Okay, you will be seeing something like this on your actual exam. Okay, and we're based on the given information. What can you conclude and why? Okay, so given that angle A is congruent. These are congruent symbols. Sorry, congruent to angle. This is bad. Congruent to angle E. Okay, so A and E. These are congruent. Okay, so there's my little congruency statement. Go a little different color here. Okay, and we're also told that AC is congruent to CE. So this and this are also congruent. We also have to remember that, I'm going to do this a little bit different, that these angles across from each other are called vertical angles, and those are also congruent. Okay, so if you look at it, we have an angle, side, angle, and I'll erase it because it's kind of messy there, but so we have an angle, we have a side, and then we have an angle. Let's see the other one. Follows the same pattern. Angle, side, angle. Again, it works out. So these here, these two triangles, in fact, are, I'm going to take all these little arrows away just so we get confused with them, there is congruency here. So what I would write is the following. So I would say triangle ABC is congruent to triangle EDC. Remember, order definitely matters. Okay, so that's how you would do this one here, and they are congruent by, again, that is, they are congruent by A, angle, side, angle. Okay, so be sure you know your congruency chart. All right, we're getting another one here that says the legs of an isosceles triangle have lengths 4x plus 2 and negative 6x plus 32. The base has a length of 6x minus 10. What is the length of the base? So remember I told you, if you're just given words, the first thing you do is draw an image of what's being told to you. Okay? So, it is, we have two congruent segments here, sides, right, because it's isosceles, means two congruent sides. And these lengths are 4x plus 2, remember, label what you got, what you're given, negative 6x plus 32, and the base is 6x over here. I'm going to go ahead and do this in blue, 6x minus 10, so we don't get confused with the base as opposed to the legs. Okay, so the base has a length of 6x. What is the length of the base? So this is what we want to know. In order to solve for this, we have to solve for x. Well, we know that the two sides are congruent, so I'll set those equal to each other. And then, of course, it's just about solving for x now. So I'll just go ahead and add 6x to both sides. Okay, at the same time, I'll go ahead and take this to the other side. Okay, so now I'm left with 10x equals 30. Okay, x equals 3. Now, this is not my answer, but I must plug it in here, right? So 6 times 3 minus 10. Okay, so this 6 times 3 is 18, and 18 minus 10, well, that's 8. So the answer is 8, right? They want to know what the length of the base is. Well, the length of the base is 8. All right. Okay, let's go ahead and move on to the next one. Again, you're given two triangles here. Given ABC, triangle ABC is congruent to triangle XYZ. AC is equal to 6n plus 8, and XZ is 12n minus 16. Find the length of AC and XZ. So remember, the first thing I'm going to do is I'm going to draw these triangles. And again, it's very important that we keep the order. So X, Y, Z as the same order as the first triangle. So we're told that AC is 6n plus 8. We're told that XZ is 12n minus 16. We're told that there's congruency between, so these are identical. So in order to solve for both of these, like we're asked to right here, AC and XZ, we have to solve for X first. So, or N in this case, 6n plus 8 is equal to 12n minus 16. Okay, I'm going to go ahead and minus 6n both sides, minus 6n. At the same time, I'm going to add 16. I'm going to add 16. Okay, so then these go away, and so does this. And now I'm left with, I'm just going to switch the terms here. I'm left with 6n equals 24. Okay, n equals 3. Now, this helps us to plug in here, and of course here. But again, since they're congruent, they're going to come out to be the exact same thing, and we'll see how that works out. So let's take 6 times 3 plus 8. So that's 18 plus 8 is 26. 12 times 3, 12, 24, 36. Minus 16. I'm sorry, here, I actually kind of messed up on this one here. Just do one here. So 6, did I say 3? And it's not 3. That's why it's coming out wrong. 6 times 3 is not 24. N is not equal to 3. I'm sorry. So it's actually not 3 here. It's actually 4, right? Something was off. So it's actually 4. So now let's try that. So 6 times 4 here, 6 times 4 plus 8. And then 12 times 4 minus 16. Right? 6 times 4 is 24. Plus 8 is 32. 12, 24, 36, 48. Minus 16 is also equal to 32. So the answer here is 32 for both XZ and AC. Okay, so you're going to see a problem like this that asks, what is the value of X in the triangle shown? Diagram not drawn to scale. All right, so the first thing I notice here are these tick marks right here. Right? That means that these sides are congruent, but also, more than just the sides, the angles are congruent, right? So that angle and this angle are congruent. So you could even say this is angle X as well. Okay, that has an X value. Now, how much is X worth? I don't know yet, but what I can do is I can say, well, 180 minus 96.5, okay, and I would get 83.5. Now, 83.5 is this here, is this angle plus this angle. Okay, so it's the rest of the triangle. I only want to know one of those axes. So in order to do this, I would have to divide this by 2. Okay? And I would get 41.75 degrees. Okay, this is equal to X. Okay, and that's how you'd figure that one out. Again, this is an isosceles triangle, which means not only are the two sides congruent, but the two angles are congruent as well. Let's move on. We're given triangle QRS is congruent to triangle XYZ. The measure of angle R and the measure of angle Y are given. We need to find the measure of R and the measure of angle Y after we solve for N, it seems like. But before I go any further, I always want to make sure that we're drawing these triangles. So let's do QRS. Okay, the first order doesn't matter, but the second one absolutely does. This is XYZ. They're the same size, I just drew them a little bit so I can fit them in here. Okay, I know that the measure of angle R is 8n plus 6, right? And that's degrees, so it's right here. And the measure of angle Y is 10n minus 16 degrees. And that goes right here. They are equal to each other, so let's go ahead and solve for n. So 8n plus 6, set both expressions equal to another, and you have an equation. So 10n minus 16. Okay, it's minus 8n, both sides, minus 8n. And I'll add 16 while I'm at it. I'll add 16 here as well. Okay, I'm simplifying this a bit, so I'll get 2n is equal to 22. N equals 11. Now, how does this help us? This only helps us in terms of being able to substitute into these values. So let's take the first one. 8 times 11 plus 6, that's 88, plus 6 is 94 degrees. Okay, and then we'll do the same thing over here. And you would substitute your values into the other one and also solve for that other angle. All right, let's move on. Okay, in this particular problem, we're asked is there enough information to conclude that the two triangles are congruent? Okay, if so, what is the congruent statement? And the answer here is yes. Okay, let me show you why. We have a right angle right here, which means we're going to use the HL, right, the hypothesis leg theorem, right, and it's in the handout I gave you today in class of the triangle congruency charts. So if this is the case, then I can say yes. Okay, and this is how it would work. It would be triangle FHG is congruent to triangle FHI by the hypotenuse leg theorem. Right? So if I have a hypotenuse, if I have hypotenuse here and here, okay, which means this leg here is congruent to itself, and I know this is a hypotenuse because of the 90 degree. Okay? Let's move on. You're asked to point out which diagram shows a point P an equal distance from points A, B, and C. Okay? There are different kind of bisectors, different kind of centers going on here. But the one that I know for sure is definitely going to be where it shows P is equidistant, right? Equal distance. So equidistance says that here A, B, and C must be equidistant, equally distant from point P. I'm going to show you here, this is actually the correct answer because of perpendicular bisectors. So perpendicular. Remember that. And remember that perpendicular bisectors create circumcenters, which in this case P is the circumcenter, and it is equidistant from all three vertices, A, B, and C. The other ones do not satisfy this. Okay, so we have this is a mid-segment theorem question. We're asked to find the value of x in the triangle shown. Remember that this side here is always twice the length of this side here. Okay, so I can write the expression like this. I could say that 6x minus 10 is equal to 1/2 of 28, right? Because again, the red longer segment is equal to twice the distance of the mid segment. So setting up this equation will look something like this. And then it just becomes about simplifying. So 6x minus 10 is equal to 14. Okay, just go ahead and solve for x now. X equals 4. Okay? And that's how you would do that. All right, so the length of two sides of a triangle are given. I've given you 3 practice problems here. You'll work on the last 2 by yourself. Find the range of the possible length for the third side. Remember, a triangle has to follow very specific rules when it comes to the sides of a triangle. You can't just throw any sides out there. Okay, so this is how you would solve the first one. So let's go ahead and take number 1 here. Okay, so if I have a triangle, right, I'm just going to draw a little picture here. Let's say this is 5 and this is 16. This leg here, right, it could look like this. I could have maybe a 5 like this and a 16 like this, right? And then the leg would be a little bit longer. I could actually bring in the 5 a little bit and bring out the 16. So there's a lot of different possibilities. But the mathematical way of doing this, let me show you here, would just be set it up like this. Remember, this is triangle side inequality theorem. Okay, so I would set up, if I have an x side, right, x inches, I don't know what that is yet, so I'm going to set it up like this. So I'm just, x is going to be my third side. Okay, so, I'm just erase that, I don't need that. So I would write it like this, x plus 5, right, so x plus the other side, which I don't know, x plus 5 must be greater than 16. I know that x plus 16 must be greater than 5. And I know that 5 plus 16 must be greater than x. So I'm going to put 3 little lines here. When I solve for these then, let's take the first one. I would get x must be greater than 11. All right, I would subtract 5 from both sides, and 16 minus 5 is 11. I could also say that x must be greater than, if I subtract 16 from both sides, I would get negative 11. And I also know that 21, x is less than 21 in this case. I just switch the x over to the left side. Now, this statement right here does us no good because lengths cannot be negative. So that one doesn't help. That's totally fine though, because all I really need is this guy and this guy. And here's how I would make my inequality. X is going to be greater than 11, but less than 21. So what that means, ladies and gentlemen, is that if I have a triangle like this, right, that's 5 and that's 16, this side right here in red, that I'm kind of highlighting here in red, this side can be between 11 and 21. So x has to be, this side has to be greater than 11, right? And this is my statement here. It can be greater than 11, but it has to be less than 21. And that would make sense because if you try to add a length side of 22, that triangle would not be able to be formed. You'd have like a little piece sticking out, and that wouldn't be a true triangle. Okay, so you're going to go ahead and try the other ones like that as well. Just follow the same scheme that I did. So I'm going to work on let me take some of this off here. Okay, so let's go ahead and work the other one here. So kind of follow the same pattern. X is my third side, which I don't know. Okay, plus 18 is going to be greater than 23. My next statement could be x plus 23 is greater than 18. And then we would add the two sides given, which would be 18 plus 23 is greater than x. Solve for those 3. I would get x minus 18 both sides is greater than 5. Here the statement would give me a negative response. It would give me x is greater than negative 5. Again, there's no such thing as negative distance, so we'll just go ahead and eliminate that answer. And over here, this last answer here would give me 18 plus 23, 41. So x is less than 41. Okay, so you're going to go ahead and follow that same scheme here. Then we would be able to say we'll put x in the middle. We'll put our little inequalities here. So x must be less than 41, but greater than 5. Okay, so the third side can be between 5, well, really like 5.1, right? Because it has to be greater than 5. It cannot be 5. It has to actually be greater than 5. Okay, so you're going to do that with number 3. You work that one on your own. It's really important that you remember this particular statement. The circumcenter of any given triangle is the point of concurrency of the perpendicular bisectors of the sides of the triangle. Remember, if you look at here, at this one here, at this slide right here, okay, this is a perpendicular bisector. Okay, this is an example of what it looks like. And we know that the circumcenter is equidistant from each vertex, which means that P is equidistant from A, B, and C. Okay, review this slide. So we'll kind of fast forward to this part we're at right here. We know that a circumcenter of any triangle is the point of concurrency. It's where the lines cross, right? Of the perpendicular bisectors of the sides of the triangle. And that's it. Just remember this statement. I'm going to take this other one here. What is the range of possible values for x in the two triangles below? So in order to tackle this, first we're going to do is remember that we're looking at degrees here. So think 180 degrees in the triangle. Right now, because of this 14 and this 18 here, right, these are basically because 14 is smaller than 18, this angle C is smaller than this angle S. We want to use the largest possible angle. So in this case, it's going to be angle S. Between the two triangles, S or C? Well, S is bigger, right, because 18 is bigger. Not because of the 20 and not because of the expression. That tells us nothing. What tells us that S is bigger than C is this guy right here, the 14 and the 18. 18 is bigger than 14, so S is going to be a larger angle than angle C. Okay, so knowing that information now, what I'm going to do is set up these inequalities, and you're going to do the same exact thing if you see something on the test like this. 20 times x is less than 180, which means x has to be less than 9. We'll do the same thing over here on the other one, and we'll say, okay, if this is 12x plus 40, which is the C, what I would write then is 20x, the angle on the other one, must be greater than the other angle C. So S must be, so I'm going to say S must be greater than C. Right? So when I substitute in the values for those particular vertices, those angles, I would say 20x is greater than 12x plus 40, because that's a value for C. We'll go ahead and solve for x, so 12x minus minus. Okay, and I would get 8x is greater than 40. X is greater than 5. Okay, these are my two statements right there. Here's how I would end up writing it. I'm going to write it way up here. I would say 5 degrees, right, because these are degrees we're working with. And I would put my extreme, my other one, over here. X goes in the middle. X must be less than 9 degrees, but greater than 5. Or you could say x is greater than 5, but less than 9. Okay? And that would be the possible range values for those particular x values in those angles. Okay, study that a little bit and get the hang of that. You will be asked to solve something very similar to this, so know this process. All right, let's go to the next one here. List the sides in order from shortest to longest. Okay, this is really important because remember we have our sides in terms of our angles in terms of which one's largest or shortest to longest, I'm talking about sides here, I'm sorry, is dictated off the angles. So the smallest, shortest to longest, so I'm going to go small, medium, long. Okay, so small, then I'm going to do the medium one, and then the long one. Okay, and that's going to be according to these angles. So if this is my medium, right, this is my small, this here would be my medium, and this here would be my long or my large. Okay, I'm going to put large. Okay, so what does that say? That means that this right here, this one right here, that's my shortest side. That side is LK. Okay, then the next one, which is the medium, I'll do it here in green, is this one here. So I go across this way, and this green one here, JK, is my medium. And of course the last one would be this one here on the other side, which is JL. Okay, something like this right here. JL. That's how you solve it, guys. So if you see something similar to this, follow the trajectory of the angles. Look at the angles that allow you to tell which one is going to be the shortest, medium, and long side. Okay. Let's go ahead and. Alrighty. So again, that's all I have for you. If you were able to go through this video, I'm not going to actually put a pear deck along with it. You just take notes by hand. Okay. Take notes in your notebooks. Okie dokie, guys. Thank you all very much for your participation. If you have any questions on how this works, you didn't understand something in the video, please reach out to me. Send me a screenshot. Mister, can you go through this one again or explain it a little bit more in detail? I'd be happy to do that, but you have to reach out. Okie dokie, guys. Have a great day and study, study, study. Test on Wednesday.